All right, guys. My voice is starting to go out a little bit, and so I think for the remainder of these videos, I'm going to show you a video of maybe like the first two examples, because all the examples are a little bit repetitious anyway, because these are all finding perimeter and the next two are finding area. But I'll give you a key for it all. I just can't talk through the rest, I think, and hope to actually have a voice at the end of this video recording time, okay? Which I apologize for, but it is what it is. Okay, so we need to find the perimeter of these two shapes. So we should probably establish like what I mean by perimeter. And so this is a well-known fact, like perimeter just means the addition of all the lengths on the outside of the shape. And so that's what we have to find. We have to find all the individual side lengths and then we're going to add them up. And so if we're finding side lengths, that means we are automatically selecting a distance calculation. And so we can use distance formula or we can use Pythagorean theorem, and I'll do kind of one of each and so we can see the total effects. As you guys well know by this point, it doesn't matter which one you use, both will turn out to be fine. And so you just have to kind of choose which one you want, all right? So with that being said, let's start finding side lengths. And let's try to be as organized as possible. And so let's first find like AB. And for this example, I'll just use a bunch of Pythagorean theorems. I think that will work fine for rectangle. And so I'm going to construct my right triangle here and just do some counting. So I have 1, 2, 3, 4, 5, and so my length here is 5. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and so for AB, we have A squared plus B squared. Okay, so that'll give me 5 squared plus 10 squared is equal to C squared. And I'm being a little bit loose with parentheses here because I know with distances for Pythagorean theorem, it'll always be positive. And so I don't think I'll need parentheses to like avoid signage mistakes. Okay, so C squared is equal to 125. And since I do have to add these all together at the end, I will convert this to a decimal. So 125 square root, so C is approximately 11.180, which seems to mesh because it's larger, it's a hypotenuse, it's larger than both side lengths, and so I feel like we're good to go on that. All right, let's keep going. So we have a distance of 4, and then 8. 1, 2, 3, 4, 5, 6, 7, yeah, 8. And so we're going to find BC. Okay, so we have squared say, so 60, 70, that'll give me 80 for C squared. And so C, so once we square root, of course, C is approximately 8.944. All right, so continuing. All right, so we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we also have, so we have DC. Okay, so 5 squared plus 10 squared is equal to C squared. Now I can notice like this is actually the same calculation I had for AB. So I have 5 squared plus 10 squared, which will give me 25 plus 100. And so I'm going to jump just right to the end. C is going to be 11.180. I suspect that this is actually a rectangle, and so I'm pretty sure my calculation was going to end up that way. But we should continue with the assumption that we don't know until we have it for sure. All right. So one last time. 1, 2, 3, 4. 7, 8. So we can look, this is going to be just like my calculation on the other side. What the heck is going on? You guys seeing that? Okay. Yeah, that's what I need right now, okay? So let's go back and recreate this. Okay, so the point I was trying to make is that this is just like the calculation of BC. We can see it's also a triangle with 4 8s. So I can just like record here. So I have AD, so A squared. Okay, so we have 8 squared plus 4 squared is equal to C squared. And so I know this value is going to be 8.944 as well. Okay, so let's go ahead and sum it all. And so the perimeter, okay, is going to be 11.180 plus 8.944 plus 11.180 plus 8.944. Okay, so I'm just adding all 4 pieces together. So point. Okay, so I got the perimeter to be approximately 40.248. And depending on how you rounded, or maybe we had some discrepancy on the rounding, it should be in that neighborhood. All right, now on the test, we're accounting for that. So don't fret. If you make a small rounding mistake, the answer should still be in the ballpark. All right, so for this one, the triangle, we're just looking for the external pieces, not the internal ones. So we're going to forget about this dotted line that has nothing to do with anything. Same thing, we're going to find the distance all the way around. I promised to mix up my approaches, and so I will. I'll use the distance formula here. So let's find AB. Okay, so distance formula. For AB, we want the square root of x2 minus x1. All right, so x2 minus x1. Again, we're going to ignore this one. We don't actually need that point whatsoever. So we're going all the way across the triangle sides. And so let's go minus 6, subtract off 6 squared. Okay, so because I'm taking x2 minus x1. And over the same interval, we're going to have 4 subtract 7. Okay, so negative 6 minus 6 will give us negative 12. And here I am using parentheses because I'm dealing with negatives. I know my result can't be negative, but I want to use parentheses just in the off chance I make a calculator mistake and type it in. I should type it in with parentheses. All right, let's try this crazy eraser. We'll see if that's, okay, it's fixed. Nice. Okay, so 4 minus 7 will just give me a negative 3. So 144 plus 9. So that'll be a square root of 153. So that'd be 12.369. All right, let's keep going. That was one of 3 different ones we have to do. So here, let's do AC. Okay, and so AC should be equal to the change in x squared plus the change in y squared. I'm just writing it differently because when we subtract, we're just finding the difference anyway. And so I'll just save you a little bit of writing because my pen is cutting out a little bit. So change in x, 6 to 4, that's an overall change of 10. So I started negative 6 plus 10 gets me to positive 4. At the same time, 4 to negative 2 is a change, in this case, of minus 6. Going from 4, subtract 6, I'm at negative 2. All right, so that gives me 100 plus 36. So the square root of 136, which is approximately 11.662. All right, last side length, the one on the right. And so this is going to be what CB. So I'll kind of sneak this one in here. So change in x goes from 4 to 6, that's going to be 2. Y goes from -2 to 7, that's a change of 9. Positive 9, not that the positive matters here because we're squaring it. So 4 plus 81, that's going to be 85, which is approximately 1 square rooted 9.21230. All right, so to find the perimeter, we're just now going to add these three values together. Okay, so the perimeter is equal to 11.662 plus 9.230 plus 12.369. And since we're rounding, I'll approximate here. 11.662 plus 9.230 plus 12.369 gives me a grand total of 33.261. Okay, so this is kind of like grunt work mathematics, like we can admit that. So we have to find perimeter, which means we have to find distances like 3 to 4 to how many sides there are total. We can use Pythagorean theorem. We can use distance formula. They're both equally good, guys. It doesn't matter which one you use. But to find perimeter, we have to, of course, add them all together. Okay. There are like 2 or 3 more pages, just like another page or 2 of this. I'm not going to make a video on that, although I will write it in as a key just to save my voice. But I think like if you understood these, you should understand the rest just fine and be able to check it against the key. All right. Thank you.